Alright, so now we're on to Punnett Squares. This is the last bit of notes for the chapter. Please cross out 3, 4, and 7, 8, 9, 10. We're going to do 5, 6, so we'll only have done 1 and 2, 5 and 6. So 5 says the chances of someone getting blue eyes is 50-50. True or false on the left-hand side. And number 6, your looks are determined by your genes. True or false on the left-hand side. Flip back to the notes. Punnett Squares. So these things are really important. These things you're going to see a lot. And they are used to show the probability or percentage, the chance of an offspring, what their genotype will look like, which determines what their phenotype, like what you actually see, is your phenotype. And so remember, genotype goes with those alleles, and we're going to start looking at those alleles. Now those alleles will then create a genotype which is shown outside as a phenotype. All right, so step 1. I know this is a little wonky right now. The table is on the next slide, so just bear with me. All right, for number 1, every characteristic that is for every single one, there's a dominant and recessive trait. And I've said these before. So the dominant trait are represented using a capital letter, like that right there. And a recessive trait are represented by a lowercase. So if it is dominant, if you see that dominant, that T, in this case uppercase T, if that is in any of the boxes, that means whatever is shown has to be that dominant T. However, if you don't have a capital letter, then you're left with a recessive, and that's what you're going to see. Okay, so one of the main things you need for a Punnett square is parents' genotype or their alleles. You need to be able to see them to be able to complete the Punnett square. So, example, we're going to have tall and short, where dad is capital T, mom is lowercase t, and short. After knowing all this stuff, having that, we can then use, once we do the other steps and then go through everything, we can use the Punnett squares to predict the percentage or the probability of an offspring's genotype, what the genes are going to look like. And then based off of that, we're going to be able to tell the phenotype what they're actually going to look like. So first things first, you're going to place one of the parents' genotypes or pairs of alleles on the top, and the second parent's alleles you're going to put on the side. All right, so I'm going to show it right here for step 4. So we're going to look back to when we were looking at the dad and the mom and the tall and the short. Dad was capital T, capital T. And for this step, because I put them on the top, for every parent on the top, drop and copy the allele. You're just going to copy it down. So there's the T. I'm going to put a T here. I'm going to put a T here. I'm going to put a T here. I'm going to drop down. So T's all the way down. And then for the second parent, you'll put them on the side, which remember was the mom with the lowercase t's. So here's a lowercase t. I'm going to, instead of going down, because there's no down to go, you're going to go across like this, and you're going to put it second. You always want to have the capital or the dominant trait first, and then the lowercase. So there's little t, little t, little t, little t, little t, little t. Okay? And based off of this, we can then determine the percentage by counting up in the box the percentage or probability. So the genotypes that we saw is capital T, lowercase, capital T, lowercase, capital T, lowercase, capital T, lowercase. There are 4 of them. They're And all four of them, when you add up the 4 boxes, it equals 100, meaning each of those boxes is going to be equivalent or equal 25 or 25%. Think of like 4 quarters equals $1. Okay, so now that we know the phenotype and that it's 100% capital T, lowercase t, now we got to figure out, okay, so what does this mean the offspring are going to look like? So it's a 100% chance that that an offspring is going to be, in this case, phenotype is tall, 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 tall. So it's 100% tall. All right. Let's try another one. How about what is the probability of an offspring getting yellow nails? So blue nails is capital V, capital B. Yellow nails is lowercase b. All right. So again, I'm going to pull down the B's, the big B's, and then I'm going to pull down the little B's, pull across the big B's, pull across the little B's. So it should look like this. And then, because I want to figure out what's the genotype. The genotype we wanted was the lowercase b's to get the yellow nails. So looking at that, that's worth 25, that's worth 25, that's worth 25, that's worth 25. I'm looking for this, and I find that right here. There's only one box, so that's 25%. The phenotype, what it's actually going to look like, is yellow nails. And again, 25%. With a 75% chance that they're going to have blue nails. All right, let's go to quiz time. Heredity quiz 2, 1, 2, 3, 4, 5. All right, Punnett squares are used for all of the following except what? This one is not the one that it's going to follow. Determine genotype, determine phenotype, probability of traits expressed, or determining personality. So everything that we just did, the one that did not happen or we did not look at is the personality. I have friends, a couple friends, that are identical twins. And what that means is those identical twins have the same, or most likely have the same genotypes and possibly the same phenotypes. However, it doesn't mean they have the same personality. In fact, most of the identical twins that I've met, and I've met quite a few, have very different personalities. So the Punnett squares will say nothing about your personality. All right. If one parent has a genotype of capital G, lowercase g, what is their phenotype? Where capital G is green hair, lowercase g is purple hair. So I'm looking at these. I've got all of these answers that are possibilities. First thing I'm going to do is I'm going to look to cross out what could not happen. Because I've got these two colors. No other color can happen. So I know gray's out. Unknown, that's out because I have the genotypes. So I'm able to figure out what the phenotype is based on the genotype. And because I have a dominant G, my dominant G is dominant. It's going to take over everything, and that's what's going to be expressed. And in this case, we're going to have the green hair. All right. If a parent has a phenotype of bumpy skin, which is a dominant trait? So the bumpy skin is a dominant trait. And in this case, I'm going to say the bumpy skin is a capital B. What is their genotype? Is it going to be capital B, capital B, capital B, lowercase b, capital B, lowercase b, or capital B or capital B, lowercase b? So you're like, hey, Miss Co, these two are the same. Yes, you are correct. They are the same. However, the answer should be D. What is the probability that number 4, that offspring will have brown hair versus black hair? Brown hair is going to be capital B, whereas black hair is going to be a lowercase b. What you should do is you should draw out a Punnett square on your own. This is a simple little box with a T in it, and you're going to follow the capital B or all the B's across. So lowercase, 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 capital, capital. So I just did 2 capitals, which means it's going to be 50%. All right, last but not least, what is the probability that the offspring will have red eyes, capital R, versus green eyes, lowercase r? And so again, you're going to follow the capital R's down, lowercase r's down, capital R's across, lowercase r's across. So there's R, R, capital R, capital R, capital R. I've got 3 that are going to have capital R's, which are the dominants, which are the red eyes, which means if 3 are there, 3 times 25, that gives me 75%. All right, let's go back to the anticipation guide. This is a little bit tricky. Number 5, chances of someone, anyone, everyone getting blue eyes is 50-50. This is going to be false because it's going to be based solely on the genotypes of your parents. It's not saying everybody has this chance. If you have a parent that has capital B for, I'm going to say brown eyes, BR, and then you have another parent who has blue eyes, which is lowercase b, what's going to show up is those the capital B's of the brown eyes. So no, not everybody has 50% chance. Some have 0% chance. All right, number 6. Your looks are determined by your genes. True or false? This is absolutely true. Your genotype determines your phenotype. Your genotype is what alleles are being shown, what alleles you have, and based on those alleles, you can tell what the phenotype, what the actual physical attributes are going to be. All right, summary. Punnett squares are useful for probabilities of the type of genotypes, which gives you the phenotype. How are Punnett squares used? In order to set up a Punnett square, you need to know the parent's genotype. And so that's the mom and the dad of whatever you're looking at. All right, that is it for the notes. If you have any questions, don't hesitate to ask. And I hope you guys have a great day.